There are three kinds of asymptotes that we're looking for. They're the vertical, horizontal, and oblique. But there are special ways you get to them to find out what they are. We'll go in order. In order to find out about the vertical asymptote, we should also find out if there are any holes in the graph. And to find out if there are holes in the graph, you factor and cancel. So nothing needs to be done for the numerator, but in the denominator, that needs to be factored out. If you factor out the denominator, you end up with x minus 6, x minus 2. If I factor it like that, do you know how I got it, or do you want to see the process?
I'd love to see the process actually.
So here, we have to factor out this denominator. So we have x squared minus 8x plus 12. Now you can do a guess and check, which is okay if you're fine using that. There's also the rule of signs. The rule of signs will tell you exactly what the signs are that you need. There are two major categories where there's a plus version and a minus version. First, you look at the C term, which is the constant. Whatever sign this is tells you which category it's in. So this means that this is the plus category. Now, beyond that, or let me go back to this part. So instead of using guess and check, or even in conjunction with using guess and check, you can use the rule of signs. This will tell you exactly what the signs are for the numbers that you find later on. There are two categories. You have a plus category and a minus category. In the plus category, both numbers are either positive or they're both negative. In the minus category, they're plus minus, but in one case the bigger number is positive, the other case is the bigger number being negative. And we have to find out which. But there are only 4 possibilities, and it's only going to be one out of these 4. First, you look at the constant. This will tell you the category. Since this is a plus, that means it's the first category, where both numbers are positive or they're both negative. To find out which sign to use, look at the B term. The B term is negative. So that means that because the B term is negative and it's in the first category, that means that both numbers will be negative. So now we know what the signs are that we'll need. What you want to do now is look at the constant and find 2 numbers that go into it, meaning that they multiply into the 12, but when you combine them using 2 negative signs, they turn into this negative 8 in the middle. You can do this in a systematic process where it's very thorough. Sometimes the numbers are small enough so you might see it right away, but if you had something in the hundreds or the thousands, it's helpful to know how to do it in a process. Start with 1. And you might see it right away, but I'll just go ahead and go through this so you see this in case you get bigger numbers later on. But here, you start with 1. 12 divided by 1 is 12. We know from the rule of signs that both numbers are negative. So if we say negative 1 minus 12, and you combine these together, this is negative 13. But we're looking for a negative 8. So it's definitely not this one. So you move on. You move on to the 2. 12 divided by 2 is 6. So now we know both signs are negative from the rule of signs. If you put these together and combine them, it's negative 8. That's exactly what we're looking for. So then now we can fill out the parentheses. Going left to right, we get x squared from x times x. 1x goes here, the other x goes there. And then after that, we know exactly what the numbers and the signs are that go inside the parentheses. You can put the -2 here, and you can put the -6 there. So this is how you can factor it out. If you want to check it, you can FOIL it back. It can take more time, but it's a way to make sure that you factored it correctly. So if you take only the first terms, which are the x and the other x, and multiply them together, you got x squared. If you take the outer terms, which is this x and this -6, multiply them together, you got -6x. You should put the -6 in front of the x for that one. Just so it matches the inner term, because when you multiply the inner terms, the -2 and the x, you got -2x. And then these two, you can see it more easily that these are like terms. The last terms from each parentheses would be the -2 and the -6. You multiply these together and you got a positive number because the double negative turns positive, and you end up with +12. Then you have these two, which are like terms. So you say x squared minus 8x plus 12 is what this FOILs into. It's the exact same trinomial we started with. That means that when we factored it here, we did it correctly. So we have the right factors. And now you'll put them underneath. You'll put them in the denominator. We'll get x minus 2 and x minus 6. If I put the top in parentheses, we see immediately that these are exactly the same. So we factored, and now because those are exactly the same, we have to cancel them. They divide out. That's what canceling means. And they're gone from this. So you simplify it. There's nothing left on the top. So you'd say that there's a 1 there really as a placeholder. There really was a 1 there the whole time. Just you won't, unless you need it, you don't write it. But there really was a 1 there the whole time. Just that now it's the only thing left there. So you definitely have to write it now. On the bottom, the only thing left is x minus 2. So we don't need parentheses for that. So because this one canceled out, there's a hole in the graph, and you can solve it. You can say it came from this parentheses where there was an x minus 6. You'd set it equal to 0, you'd add 6 to both sides, and you'd say there's a hole in the graph when x equals 6, or at x equals 6. But because we're just trying to find the asymptotes, we still needed to find out about the hole, because if it's a hole, it's not an asymptote. So now that we know that that one cancels out, now we can find out what the vertical asymptote is. This is where you set the denominator equal to 0, and you solve. You're going to find an equation. You're using this denominator, the one that results after the factoring and canceling. So the only thing left here is x minus 2. That equals 0. And you go ahead and solve for x. You add this to both sides, and you get an equation where x equals 2. And that's it. That's the entire vertical asymptote. That's it for the vertical asymptote. So far, do you have any questions about anything?
So far, no, I don't have any.
Now, the second part. Here, now we're trying to find out if there's a horizontal asymptote or an oblique asymptote. It'll be one or the other. If you find one, then there won't be the other. Now, here's one way you can remember it. You'll have a function. You'll have something in the numerator, but you're only looking for the highest power term. In this case, we'll stick with x. And let's say the exponent is an m, and the coefficient is a. There can be other things, and it can be out of order, so you just have to watch out carefully to make sure you're picking the highest power term only with the sign in front of it. In this case, there's just the x minus 6, but I'll just indicate that there can be other things here. For the bottom, we have bxn. And there can be other things here, but only the highest power term matters. So the a and the b are coefficients, the m and the n are powers, or exponents. And you're looking at three cases. In one case, in the first case, you have the numerator's exponent. If it's less than the denominator's exponent, that means the denominator has the higher power term. And so you get an automatic horizontal asymptote with the equation y equals 0. We immediately know that much, that the equation will be y equals 0. Then there's another case where these are the exact same number. M and n are the same thing. If that happens, you still have a horizontal asymptote. It's still a y equals equation, but now you make a fraction. You set a ratio where you have the coefficient a, whatever number might be there, will go on the top, and you'll have a b on the bottom. And then if it's a number, for example, if a was a 2 and b was a 4, you'd want to simplify it. That's one way to get the horizontal asymptote equation when the powers are the same. So these are both horizontal. There's a third case where if the numerator has the higher power, then this is no longer horizontal. This is now an oblique asymptote. And that means that it would still be a y equals equation. So that part is the same for all three cases. It's y equals something. But you have to find out what this is on the right side using some form of division. Synthetic division usually works. You can also use polynomial long division. So here it is. It's only one of these three cases. If it's either case 1 or case 2, it won't be case 3. Or to say it the other way, if it's case 3, it can't be either of these two cases. So that's why you either have a horizontal or an oblique, but not both. So from our function, on the top, you're only looking at the highest power term. It doesn't matter that there's a minus 6. The highest power term is x. So that's what you put on the top. If you want to fill it out so that we can also see m and a, you can do that. You don't have to here because it's 1 for both of them, but if you wanted to, you could say that there's a 1 here, the understood m, or the understood 1 is the m. There's also a coefficient here. The coefficient is 1, and it's understood. That's why we didn't see a number. From the denominator, this is in order, so we can see immediately that the highest power term is x squared. That's the only thing you write here. We don't need the other things. So the n here is the 2. The 1 here, that's the b. And what you're looking at is, which one is higher? M is a 1, n is 2. Because 1 is less than 2, m is also less than n. That means that we have this case, where m is less than n, which means we have a horizontal asymptote, and the equation is automatically y equals 0. In this case, because we found a horizontal asymptote, there's no oblique asymptote. And this is everything we needed to know. We needed to find the asymptotes. We found the vertical up here. We found the horizontal one down here. And we know that there's no oblique asymptote. For this, do you have any questions about anything?